Chapter 6, Exercise 4.1. So the first thing to notice is that all those objects have the same mass, therefore there is the same force of gravity acting on them. And you can see this over here. They all have a force of gravity of 1 kilonewtons, which is 10,000 newtons. Now, how big are those objects? So let's calculate the volume of each object. We know that density is mass over volume. So volume is mass divided by density. And the mass is given 1,000 kilograms divided by density. So I can do that for bamboo. For bamboo, I will get 1,000 kilograms divided by 300 kilograms per cubic meter, which gives me a volume of 3.33 cubic meters. Now I do the same for aspen, and I find 2.5 cubic meter. And I do the same again, this time for ice, and I find 1.09 cubic meter. This is the total volume of the object. What I see is that bamboo is a lot bigger than ice, and that's expected because they all have the same mass, but bamboo is less dense than ice. Now if I want to calculate the buoyancy force acting on each of those blocks, I need to know how much of the block is submerged. So for example, for a given block like this, if the water level is there, this is the volume submerged. It is also the volume of displaced water. To calculate this, I need to know d, which is equal to the density of the object divided by the density of the fluid. And the volume of the displaced water is equal to the total volume times d. So total volume times density of the object divided by the density of the fluid. For bamboo, the volume of the displaced water will be 3.33 cubic meters times 300 kilograms per cubic meters divided by 1,000 kilogram per cubic meter. And this is equal to 1 cubic meter. If I do the same calculation for aspen, I find 1 cubic meter, and for ice, I find 1 cubic meter. Therefore, the mass of the displaced water is going to be the same, and the mass of the displaced water is equal to the volume of the displaced water times the density of water, which is 1,000 kilogram per cubic meter. So for bamboo, the mass of displaced water will be 1,000 kilograms. And the calculation is identical for all of them. What you notice here is that the mass of the displaced water is equal to the mass of the object. Now if I calculate the buoyancy force using a value for G of 10 meters per second squared, then Fb will be 10 kilonewtons, 10 kilonewtons, and 10 kilonewtons. What you notice here is that for all those objects, Fg and Fb are the same. That's because we have a static equilibrium. And because all of the blocks have the same mass, they also all have the same buoyancy force. So what happens is, for the bamboo block, that block has to sink less than the ice cube in order to provide 1,000 kilograms of displaced water. In the case of the ice cube, it has to be 92% submerged to provide a displacement of 1,000 kilograms of water.